All right. Last bit of differentiation, we're going to look at optimization problem. So you need to recall the optimization process using the calculus techniques. This time, you can actually apply the second derivative test rather than the sign test to determine the nature of optimal solutions. And then solve optimization problems in a variety of contexts over infinite and finite domains. All right. Let's start thinking about optimization. It is a process of obtaining the optimum or best solution to a practical problems by finding the minimum and or maximum values. So we can use calculus techniques, differentiation, and appropriate calculus test. So I said appropriate calculus test. You may need to use sign test, but generally, in this case, you can use your second derivative test now to determine the nature of the solution. All right? Think about what is happening here. So if we have got a finite domain, all right? So if you want to find the minimum and maximum, of course, we can use first derivative to find the stationary point, which could be the mean, could be the max, correct? Now, the issue is, if you don't have the graph, you don't know the mean and the max. Therefore, you can use your second derivative. The third problem is, because we've got the endpoint, A and E, all right? We don't know whether A is higher than D, or E is lower than B, all right? So what you really need to do is, in certain situation, you really have to think about what the endpoint is. The endpoint might be the best solution, all right? So in this situation, if I extend that point E, if I want to find a minimum cost, all right? If I extend the point E, it may go all the way down here. And that could be the situation, that could be your point E, that's the minimum solution. It's not the stationary point, but it's the end point. All right? So you've got to be very careful when you look at situation like this. So my advice is, if you're in a calculator assume section, just quickly plot the graph. And then you can see where the endpoints are. All right? Now, these are the seven steps generalization of the optimization process. First, you need to interpret the problem. Then you need to think about, if there's a diagram given, annotate the diagram by putting information in, or draw a diagram. So diagram is one. Then establish a function in one variable to be optimized. Not two, not three variables, just one. Differentiate the function, solve the derivative equal to 0. That's the nature of the solution, using sign test or second derivative test. All right? Then check the endpoints of if there's a finite or defined domain, not of if. All right? And then answer the question in context of the situation. Now, what you're doing is actually finding the stationary point in the contextual situation. You know how to use your dy dx to find the stationary point. But here there's context to it now. All right? So let's think about example 1. A cylindrical bucket has to be designed such that it has a capacity of 10 liters. Determine the dimension of the bucket if the amount of sheet metal to be used in its construction must be kept to a minimum. So imagine that this is actually a bucket, but it's not a cylindrical. Imagine this is a cylindrical bucket. All right? So you have the base here with the radius, right? And the base, and then you've got the rounded side. All right? So it's not a square, but it's round side. So you don't have the surface. There's no top. You just have the bottom and that side. So you should draw a diagram. All right? What I did was I highlighted the information first, amount of sheet metal to be kept to a minimum, so that I know it's the minimum we're looking at. So define some terms. I let R be the radius of the bucket in centimeter, and H be as the height of the bucket in centimeter. So I use centimeter because I know the capacity is 10,000 centimeter cube. All right, 10 liters is 10,000 centimeter cube. draw a diagram so that I know what's happening. So I can work out what the volume is, correct? So volume of, sorry, not the volume, the surface area. I have one base and then the body, the curved body. So S surface area is pi r squared, bottom, the base, plus 2 pi r h. And you know volume is pi r square h. You've got two variables there, r and h. So you either have r in terms of h or h in terms of r. Now, look at this. You know the volume, you know it's pi r h, pi r square h. Volume is 10,000 centimeter cube. So I will write down volume is pi r 10,000 equals to pi r square h, and therefore I've got h in terms of r. And you know that r has to be greater than 0. Alright, I will let you try it out first. Substitute h into s. The reason why I use h instead of r is there's r squared here. If I use h, I will be thinking about a square root, a radical. So I'd rather have r squared here and substitute h in there. Makes life just that bit simpler if I don't have to deal with radical. I don't mind dealing with square or cube or whatever, but prefer not to deal with radical. That's my personal preference, but it's up to you. So you need to be able to find the S, the R, and there should be a minimum. The S, the R should be a minimum. It's a lot of substitution. So this should be the basic example that you know what to do, volume. Alright, if you find, substitute h. So you know S equals to pi r squared plus 2 pi r times 10,000 over pi r squared. And simplify it. Get rid of the pi in the second term and get rid of one of the r. Basic calculus that you need to know. All right. Now, keep going. The SDR is just 2 pi r minus 20,000 over r squared. R to the power of minus 1, differentiate that is 1 over r squared. Alright, so therefore you've got that. So you know the SDR equals to 0. We can solve that. Now of course, in this situation, you could actually use a class pad to solve it, but I wrote it down. I wrote it out. I was never trained to use calculator when I was your age. I was not allowed to use calculator at all. So we have to do everything like this. Therefore, I'm so used to doing it that I don't use calculator. All right? Do you get this so far? Once you've got R. Now, you cannot stop there yet. Because you need to find, to check whether it is a maximum or minimum. So you need to do a d2r, dr squared. Second derivative, d2s, dr squared. All right, second derivative. Second derivative of ds of s should give you that. So, and then you should substitute R in. And you can work out whether it's positive or negative.
What'd you get?
You use your class pad. Use your class pad. Use your class pad. I'm going to work this out at 6 pi, and which is greater than 0.
What?
Alright, this sort of question is solvable without calculator. It's solvable without calculator because you know you can work it in terms of pi.
I must have did something wrong.
So it may potentially be the last question in the calculator
I might be wrong.
free section, this sort of question. Alright? I mean, you could use calculator, it will make the process so much shorter. And then you know that it's a minimum at R. So you can work out what H is. So I did everything without calculator, but it took me a long time.
What's the decimal answer for that?
Yeah, it took me a very long time to get it out because so R is equal to H to minimize the amount of the sheet metal. So sometimes this sort of question will be tied to cost. You'll need to work out the minimum cost. Alright? The minimum cost is linked to the minimum sheet metal you use.
No.
Alright, therefore
Should be 14.7.
that's how you answer the question.
Yeah.
I don't know.
Alright, let's go to number 2, please. I had to reword this question because when I first looked at this question, it took me half a day, I still couldn't solve it. Then I realized why. It wasn't worded. It was something that I did not anticipate, so I had to reword it. So it says here, a long sheet of metal, 30 centimeter wide, is bent in thirds. So you've got the information that bent in thirds to form an open gutter with a cross section of an isosceles trapezium. So an isosceles trapezium in this case, isosceles trapezium means it's a trapezium where you connect this together. These two are the same. Alright? Now the further information is it bends in third. So here should be the same as that, should be the same as that. Correct? Yeah? So can you actually draw a diagram, please?
I thought it was cross section.
So therefore, you know that this angle and this angle should be the same because it's an isosceles triangle. If you connect these 2 points.
Shouldn't it be this?
Right. I'm just going to give you a couple of minutes to draw the diagram.
I
Always draw the diagram in this case.
So, I think. So, wouldn't the question more say that the gutter is like,
Yep.
and then the cross section is this and this, so then all of these are the same?
Yeah, cross section is that basically the area of that. Yep, that's correct. Not.
But didn't you
not,
say it was?
Yeah. That is
that the
the
same
explaining. That's explaining what isosceles trapezium is.
So what are you trying to?
That's what isosceles trapezium.
Okay.
So how would you?
Oh, right.
Yep. That's the explanation. Isosceles trapezium just means that if you connect those 2 points, it becomes an isosceles triangle.
So that's the same as that.
Yep.
Okay.
Now, what is a cross-sectional area? Cross-sectional area is basically, imagine this is your trapezium, all right? And I didn't draw it properly. This is the area that you're looking for, and you should know the area formula for trapezium. I think it could be in your formula sheet. Yes, for measurement, the area for trapezium is in there, half A plus B times H. So this is A, this is B, this is H. It's half A plus B times H. Now, there are several ways or 2 ways you can do this. Plotting it or drawing it, this is what it looks like. All right? So it's folded in a third. You've got 10, 10, 10. And because this is isosceles trapezium, you know that this angle is the same as that angle. Therefore, if the angle formed with the vertical with h is theta, there will be theta as well. So you can actually see that if you do not want to use the trapezium formula, you've got two triangles here, right angle triangle. You can use the rectangle plus the two triangles to find the cross-sectional area.
Yeah.
Correct? Yeah?
Yeah.
So you could do it that way as well. But you might want to just use half AB area equals to half AB times H. What I've done there, here, it says here, given the slope side of the gutter, make an angle of theta. So there's theta, both these are the slope side with the vertical. Show that the cross-sectional area of the gutter is given by A equals to 100 times cos 1 plus sine theta. Alright? So, when you draw a diagram like this, you need to think about how you're going to relate this to h or to the theta. Here, you want everything in theta. So you're going to relate it to theta. Alright? So first, I draw this, and I know that if this is 10 centimeter, that will be 10 centimeter as well. Because it's isosceles trapezium, that is the same as that. Alright? So you know that that's 10 plus 2L there, and there's 10 there. And you need H. Alright? So, here, B here is 10 plus 2L. Now, you don't want it in L, you want it in being theta. Right? And H as well. You do not want it in H, you want it in terms of theta. Because your equation is in theta. So you're going to think about that, how you're going to find L in terms of theta and H in terms of theta. Right angle triangle, you know this theta. So therefore, sine theta is L over 10. Which therefore L equals to 10 sine theta. Cos theta is H over 10. Therefore H is 10 cos theta. Happy? Once you've done that, can you try to establish the area, please? Alright? Using the formula A equals half AB plus H. Or use your rectangle plus the two triangles. It's up to you. It will end up to giving you the same answer. So I'm going to stop there for a while. I'll let you do it first. See if you can come up with A. A equals to 100 cos theta, 1 plus sine theta. Now, answering question like this, the trick is, if you cannot come up with the area, doesn't matter, skip straight, use the area and go straight to B. Alright, that's the exam technique. A will have less mark than B. So straight away use what is given. That's the exam technique that you need to learn.
Oh, this is actually very simple.
So which angle is actually theta?
Theta is with the vertical. See that?
Wow. Did you get it?
The slope side with the vertical.
No, I didn't get it.
Oh,
So
Theta.
oh, I thought you
So-
meant like when if they join together.
Oh.
That's here.
Oh.
Alright, not the whole angle. And what is the constraint for this one? What can theta not be?
It can't
Maximum.
be more than pi on 2.
Has to be in the first quadrant.
Yeah, it should be in the first quadrant. Think about it. It
0 to
cannot
pi
be.
on 2.
It
Can't
cannot
be
be
90
zero.
degrees.
If it's zero, it cannot be a gutter, can it?
No.
Because it's flat. So it has to go all the way up, possibly maximum of 90 degrees. That's all.
Yeah.
Alright.
Can't be
You
90.
you can fold it all the way in, but then
0 to pi on 2.
yeah, it doesn't work. It doesn't work as a gutter. Alright.
Oh, we get to do
So if you
No, like
the area is half 10 plus 2L plus 10. Alright? Times H. So you know it is 10 plus L times H. You can work out what L is, sine theta, and what H is, tan cos theta. So therefore, this is how you work out the area. Like I say, try if you want to work out as two triangles and one rectangle. Or in fact, if you think about it, if you move this across and flip over, you actually have two rectangles. 10 times h plus L times h. Alright?
Yeah, no, I am doing.
So it's the same. 10 times h, L times h, you use the distributive law. So either way, you should come up with this. And calculus technique.
Wait.
Yep.
You did 10 times 10 is 10. 10 plus 10 is
10 times 10 is
10.
10 plus 10 sine theta.
No, it says A equals half 10 plus 2L plus 10.
Yep. So is half 10 plus 10 is 20. 20 plus 2L times half is 10 plus L. Hang on. That here. Here.
Yeah.
Alright. So it's half times 20 plus 2L.
Yeah.
Correct? So multiply half in. I've got 10 plus L. I'll skip that step. That's all. Alright. From there, you should be able to do your first derivative.
10.
I always take the constant out, which is 100 out, so that I have got I work on whatever is in just the sine and cos. So go back, if you look at it, I work on cos theta first times 1 plus 2 theta, and then work on 1 plus 2 theta times cos theta. Alright, it's a product rule. Now.
And you have to solve it in the first quadrant.
Yep, you have to solve the first quadrant. So now, this, you can see that it becomes a cos squared
No
minus
solution.
sine
What?
No.
minus sine
Why
squared
not
theta.
give me no solution?
You've got to go back and think about what you've learned in year 11, your
Let me
trick.
do this. Let me do this.
Sine squared theta plus cos squared theta equals to 1.
Look,
Mate, you're not right.
Alright, so therefore, cos
Have you done
squared
it?
theta
No.
equals to
Oh, wait,
1
no.
minus sine squared theta. Go back to what you've learned in trick. And then you should be able to factorize it. So cos squared theta is now 1 minus sine squared theta.
We go. Oh no.
in the slope.
Go. Easy. Come on, this is the solution. Look how long it's taking. Yeah, there we go.
Bro, what?
Totally agree with me?
Oh, I'm in gradients.
So far so good? In radians, not in degrees.
Yeah, yeah, sure.
Yesterday somebody was solving a problem with degrees. I can't remember who.
Wow.
Okay, yeah,
Why would you go
that's
into
the graph
degrees?
looks
It's
not
year 12,
right.
mate.
I can't remember.
Year 12 was all radians.
So remember, it's in gradients.
It's because I left it
radians,
on when I
what
put it in my
radians,
bag. So
radians.
like, I don't know.
Wait, does
It
that mean you
changes.
use the
It's
Now,
pints.
You use degrees now.
Here, what I've done is, I've actually taken the negative out as well. So if you are not sure how to do something like this, how to factorize like this, assign x to sine theta. Alright, that is actually minus 100 times 2x squared plus x minus 1. So, if you're not sure about factorizing something with a square of sine theta, just assign any pronumerals as a sine theta so that you've got 2x squared plus x plus 1, which means you can factorize it in the way that you are used to it. Alright? So once you've done that, substitute your sine theta equals to x back. Alright? Think about this step. If you're not sure how to factorize that, think about this step. Let sine theta be x. So you should be able to factorize that, which is 2x, x, 1 and 1. So I need minus 1 plus 1 minus 1. Yeah? So that's how you actually do it. Once you've done that,
negative.
You should work out
So therefore,
dA
Pi
d
on
theta
6
equals to 0.
is maximum.
So sine theta equals to half or sine theta equals to minus 1. Now think about your unit circle. Can I accept this as an answer? Sine theta equals to minus 1?
Yes.
Can you? Where's sine theta equals to minus 1?
No, you have to
No, you can't.
solve it for theta.
You really cannot accept sine theta equals to minus 1. So you can only accept theta, you know theta is between 0 and pi over 2. So therefore, you need to reject sine theta equals to 1 and theta equals to pi over 6. Alright, the next thing you need to do is find dA d theta. Correct? Now, what I would do is, when I do my derivative, I will not use the factorized form.
1 to 9.
I'll use that.
1.
Alright? I will use that. I will not use the factorized form
Centimeter squared.
to find the second derivative.
I did it.
Alright? That you don't have to, you have to involve chain rule, but no product rule. This one you have to involve product rule and chain rule. Alright? So I use the non-factorized form, and I can work out d2a d theta.
Just use your
Alright?
calculator.
And work out it is less than 0, therefore it's maximum. Now, in this situation, because most people will not understand what pi over 6 is, if you say the angle is 30 degrees, you will accept it. Alright? If you go out, if you talk to the tradespeople fixing up the gutter, they will have no idea what pi over 6 is. They will know 30 degrees. Alright? Yeah, I am going to tell you that's a fact. So it's not that they are not used to measuring radians. They will know 30 degrees or approximately 30 degrees. Alright? Now last question will probably be the hardest question that you will get in this one. I'll have a harder question tomorrow.
So you didn't finish the question.
Sorry?
You didn't finish it. State the maximum area.
Oh, I haven't. Oh, gee. Sorry.
That's 1 mark, sir.
Yes, it is 1 mark. Yes, if I didn't calculate the area, it's 1 mark. Yes, my fault. So I'm going to substitute in. It's true, it's my fault. So I will leave it to you. Yeah, it's probably a couple of marks.
Try the next one, mate. I bet you'll get it.
All right, next one. This one. Now this one, if you were in my class last year, you would have done something like this.
Oh, nice. That's me.
If you remember, that's good. If you can't remember, don't worry. Let's try. So you need to think about Pythagoras' theorem in this case. Alright? One is traveling north-south, the other one is traveling east-west. North-south highway intersect east-west highway. Alright? So, if you look at this, you should start thinking about something like this. North, south,
Actually, they changed it this year, never mind. That's right. No, they
east,
changed it 2023.
west. Alright? If
That's
you've
2023.
got that,
Yeah, this
you
way.
can start thinking about where the position of the car is. Alright? And you need to include things like speed and distance travel. North, south, east, west.
So why does it say estimate minimum distance?
Because when you do, you're not getting the exact value, so estimate. Decimal is always decimal estimate.
Oh, fair enough.
Yeah.
Right.
This one you definitely estimate. You have to estimate to do decimal places.
Okay.
So if you think about where P is, north-south highway intersect east-west highway as point P. Alright, this is point P. The vehicle crosses P at 10 a.m. traveling east at a constant speed of 4. At the same instant, another vehicle is 44 kilometers north of traveling south at 100 kilometers per hour. Determine the time at which the vehicle are closest to each other and estimate the minimum distance between them. So someone is traveling east at a constant speed. So the vehicle is traveling this at a constant speed. Alright? And the other one is moving down this way.
1.4.
Alright? So, when you draw, this is the vehicle coming down, this is vehicle traveling over there. Alright? Yeah? You know that this is right angle.
Distance for.
Right?
I don't know when
So
T
you want
is
the
0,
distance closest, which is
R
this
is
distance.
the
No,
distance is 4 kilometers.
Okay.
At the very,
Something
very
like this.
start.
No, it's not.
Yes,
It's
it
just not,
is.
isn't it? It's just not.
Because
is.
you've got the distance where it has traveled. Originally, this car was here. It's moving from here to here. And that one is moving down south. Alright? So this one started, vehicle one, started from here and go across there. This one, this vehicle moved down. Correct? Yeah? So you need to think about how to find the distance here, how to find the distance here.
Is time in hours, sir?
Sorry? You
Yeah.
can use hours because the speed is in hours. The speed is 40 kilometers per hour. So you need to find the distance.
Would you?
Wait.
Inspect. No. Oh, it sort of is like that. Except we don't use FMA.
Alright, I'm going to show you what I've got from the book. So what I've done is, hold on, I let T be hours after 10 a.m. Time is hours 10 a.m.
Yeah.
and E is the distance traveled by the car along Northeast
Sort of
Highway.
is like that, yeah.
East-West Highway, and N is distance traveled, North-South Highway, and D equals to distance between them. So this is what I did. So you know N
4 take 100.
is traveling downwards, and it's 100
plus.
T,
40.
because there's distance,
But
there's a
down.
time
Is
after
that your
10 a.m. 100
Yeah,
kilometers
you're
per hour.
optimizing.
This
But
one
yeah,
is
yeah. But
traveling
was that your opinion?
40 kilometers per
Yeah.
hour. Alright, 40 times T.
Not too
They both travel. Originally, this car was out here, and this is directly north. Alright, starting from here. So when this vehicle travel this distance, the same time this vehicle will travel this distance. Alright, this diagram is exaggerated. So you can work out here
This
is
way,
this is 4 kilometers, so it's 100 T, is therefore this is 4 times 4 minus 100 T. So basically understanding the diagram, how do you plot, how do you draw it is important. How do you link the distance to the speed is
Do you
important.
find- do you find
How
F
do you
min?
define the time is important as
Do
well.
you do F min of this?
No, I differentiated in stationary point. And then
Once you have established this, you should be able to
but
find
doesn't-
D.
You can just use F min.
yeah, because it doesn't
Alright.
say calculus seconds.
Does it not?
It doesn't say calculus seconds.
Now, I've got a question for you. We are actually looking at Pythagoras' theorem. So
Yes.
we know that we have D squared equals to 4 minus 100 T squared plus 40 T squared. Alright?
What do you T, sir?
Question.
Yeah.
40 T squared. Oh,
God.
sorry. Now, question for you. Do
0.035.
you want to find the square root?
Cool, and then
Why don't you give me some collab terms?
Do you want to find the square root? Alright. I've got another question for you. If D square is maximum, is D maximum?
No. Because D squared, D could be negative, so it would be minimum.
It can't be negative because it's distance.
Oh, okay, I've done it.
It can't be distance. This line is distance. Distance cannot be negative. So, yeah, you gotta think about, be smart. You are not
0.035.
finding D
So here you go.
D distance
Just not
dt
what I'm
over
getting
dt.
at.
Alright? What you're going to do is find
just
d
ease
d
this,
square over dt. Alright? This time, be smart.
Right.
What you need to do is optimize d. By optimizing d, you can optimize d squared. Correct? Because if this is minimum, there'll be minimum as well. Correct? This is maximum, this is maximum as well. Agree? So therefore, we know that d squared, d cannot be negative. So therefore, we can optimize d squared. And then work backwards to find
That's
d.
what I got.
That's why I say this question is not an easy question. You've got to think about using d squared. So what I've done is, I know that to avoid the confusion of using dd over dt, I
Is
call
it
it
right, though?
ft.
I think so.
I've already got ft, and then ft equals
Now
d
it's
squared.
just simple. Just
So,
differentiate, find the stationary
Therefore,
point.
I can find the stationary point by taking the first derivative
Did you
of
find the
ft.
time though?
Alright?
Yeah, and then I found the
Yeah.
distance.
Wait, oh, do we have to find the time? Oh, yeah. Did you find the actual time though? Like,
Yeah? Are you all happy with that so far? Yeah?
Um,
So, with that, you should be able to work out t is
Yeah, chain rule.
about 0.0345 hours.
So you probably expanded it all out.
Yeah? And now,
It's just-
this one, if you find the second derivative, straight away you know it's minimum because the second derivative is just a constant and it's greater than 0, so it's minimum.
I think you actually got
at
it
t
wrong
equals to that.
because you didn't write the actual.
So you can work out d as approximately 1.49 kilometers.
Fuck you, man.
Now, when you think about calculus, sometimes you got to think about when you're maximizing or minimizing something. If you look at that value, you might think about, can I use some other value to substitute for that? In this case, you are using the d squared as proxy. All right, maximizing the d squared, and d is automatically maximized or minimized. All right, this sort of question, you need to think about using that. All right, I'm going to stop here, and tomorrow I'll give you some other 3
Did
more
you get 1.49 kilometers?
optimization question.
Do you get 1.49?